Welcome back to CSC 143, Intro to Data Structures. This is the second lecture for Chapter 10 of ArrayLists, and we're going to be covering comparable compareTo. So just to remind you what we covered in the previous video, and if you haven't found that video, just like and subscribe to my channel. So for section 10.1, we covered basic operations, how to search and manipulate your array lists, how to add and remove, and the complexities of doing that, using the for each loop and the complexities with that, and wrapper classes. So this section is entirely about the comparable interface and the compareTo function. These are actually very important and underrated. I don't spend enough time in my classes on it, but it's very important, and I'm going to try to go over it with a good example for you to see. You may remember from Chapter 9 we talked about inheritance and interfaces. We talked about having just regular classes where you put all the code in. We talked about abstract classes where you can have some code, but you're not supposed to instantiate an abstract class. You're just supposed to inherit from it, and then the subclasses can use the code in that superclass. And then finally we mentioned interfaces, and I think I mentioned that I would be revisiting this later. So interfaces have no code whatsoever. It's just a set of functions that a class needs to implement in order to provide functionality to other classes. And so this is the first example of what an interface really is and how it's useful. Let's take a look at some slides. So far, we haven't talked about interfaces. The motivation for talking about the comparable interface is that many times you have a class which has some sort of natural ordering. So for example, I'm going to show you some code that implements a time class. So it has an hour and a minute, and it's not exactly intuitive how you want to sort those. You don't want to sort them as a combined hour-minute. You want to look at the hours first, and then you want to look at the minutes separately. And so whenever you have a natural ordering, you want to be able to sort things. And wouldn't it be nice to not have to write your own sort routine? Well, Java has done that for you, but in order to be able to sort your data, you have to implement an interface. This interface is called comparable, and an interface again is a class which has no methods, no code I should say, but only has method headers that a class has to implement in order to be able to be treated as this type of object. So the only method that you have to implement for the comparable interface is a method called compareTo. Now the first thing I should warn you is that the terminology here is always confusing. Okay, so one thing that'll help is the interface is more generic, so it's comparable. Okay, it's not compareTo. If the interface is comparable, the actual method is compareTo. The second thing that'll help is the capitalization. So interfaces are capitalized. We start with a capital C, and then methods are not. So it's compareTo, just like toString. To start is lowercase, and then string is capitalized. And then the third thing that's confusing is that comparable and all other interfaces typically are going to be parameterized. So here there's a parameter type T, which you need to actually put a real type in when you're going to define that your function is implements the comparable interface. But then in the actual method, it's not a parameter, it's a regular parameter. Sorry, that's confusing, right? It's not a parameterization, it doesn't take a type, but rather it takes a regular formal parameter of that same type that you've mentioned here. But we're going to go to the real code, and this will make more sense. But those three things are things that always confuse me. So the compareTo method is a comparison function, and it actually returns, you might think it returns a Boolean, whether it's false or true, but it's actually an integer, and it's going to return either a negative number, 0, or a positive number. And so it's the only method required to implement this particular interface, and every interface is going to be different. So here it talks about the T is short for a type, and you have to replace it. And two objects cannot be compared directly using relational operators, so you can call the compareTo method here, and this will tell you whether object is less than object 2. So it's the S1 here would be the this, okay, and S2 is the parameter. So this is kind of a side benefit of the compareTo method. You're rarely ever going to actually write compareTo yourself. What you really want to do is to be able to give it to a function that will sort it for you. Okay, many standard classes implement the comparable interface. Again, because it's such a useful interface, it allows you to sort your data. And here's an example here of a public class that's being declared. The name is calendar date. And then here's what we're adding now. So you use the keyword implements, and then you put the name of the interface. And interfaces are always capitalized, so it's comparable. And then you need to put the parameterized type here. So imagine there's a type calendar date. Okay. And in addition to that, so you put this in the header of your class. So if you wrote a public class calendar date, what you're going to do first is you're going to, sorry, it's hard to highlight this exactly. You're going to declare your class, then you're going to add this new part. Okay, you're going to say implements comparable calendar date. Then you actually have to declare the compareTo method and implement the method. Otherwise, you're going to get an error. So here's a code example. Again, this is using the calendar date. So unfortunately, the class definition is not included here. That's where it would say implements comparable calendar date. But here it shows the implementation of compareTo calendar date. And what it's doing is apparently there's a month field. So it checks whether the month is less. And if so, it returns a negative month number. Otherwise, it's going to return. This is actually going to be returning, interesting, month, other month. I would have thought that maybe it should be month doesn't equal other month. And because this is going to return a positive or negative number. And then otherwise it's going to return the difference of the days. So it'll be a positive or negative number right there. And so here you create an array list of my dates. And you do need to create an array list in order to be able to sort, because the Java collections work only on Java collections real objects. Okay, you can't use an array because an array is primitive. So, but you create an array list, you add the dates here, you print it out, then you can call collections.sort on my dates. Okay, and then you print it out again. And here you can show examples of comparing between the two dates. Okay, so I'm going to be showing some code in Eclipse now. I'm using the same class that I created for the 10.1 lecture. So we were working on this SumInts before, so I've replaced it with a call to a times function. And I've declared the times function down here to similarly, just like with that slide we just looked at, we're going to create an array list of times. We're going to add a bunch of new times. We're going to print it out, sort it, and print it. Okay, so let's take a look at the time class that I wrote. So pretty basic here, class time, but here's the key. It implements comparable time. Let's just for a moment take this out. Let's say that I don't declare that. What's going to happen down here, a little bit down here. Okay, so here's that collections.sort. If I try this on it, it's going to say that the method sort in the type collections is not applicable for the arguments ArrayList times. So because it doesn't know that it implements the comparable interface, but implements comparable of, and again the type parameterization, you have to put in the time class, okay? And then this is all just basic constructors and getters and setters and string format. Here's the real meat of what we want to do. So we have a this time, okay? So there's a this hour and a this minute. Okay, and then we've got a time parameter passed in. So there's a t hour and a t minute. So I'm just simply checking. First, the hours are the most important thing. So I check whether the hour is greater. If so, then we know that the answer is greater. Or if the hour is less than, we know that that's going to be less than. And this is not absolute times on a clock, but these are meant to be lengths. Okay, so I'm not worrying about 11:59 versus 12:01. That's another thing you would have to consider, though, if this time was actually regular clock time. Okay, so but assuming that the hours don't override the situation, then it's down to comparing two same hours, and now we're down to looking at the minutes. Okay, so anyways, the code here is not complex, but the point is it's going to return positive, 0, or negative 1. Okay, So we've implemented this interface, and by implementing that function and declaring it that it implements comparable, we can now pass this into collections.sort. So the collections is a class and sort is a method, and it lets us pass in a method which implements the comparable interface. So now when I run it, so it starts out with 5 hours, 30, 2 hours, 30 minutes, 55 minutes. Now it's going to sort it. So 30 minutes, 55, 2 hours, 5 hours, 30. So that's an example, a great example of why you want to implement the comparable interface, and more generally of how are interfaces relevant. So for example, this collections method here has nothing to do with the time class. The collections class has nothing to do with the time class, but the collections class implemented a method sort, which can take anything which implements the comparable interface and sort things. Okay, so there's a sorting algorithm built into the Java collections class. So I'm able to take advantage of that Java collections interface and sorting in particular because of interfaces. And what are interfaces again? Interfaces are not inheritance, normal inheritance, because there's no shared inheritance between my time class and the Java collections class. It's that there's an interface that defines the comparable interface. Let me actually quickly show you on the internet what happens when you look for an interface. Okay, so here's a Java collections definition of the comparable interface, and you can see it's an interface, the name of the interface, and then a type. Okay, and then that type needs to be replaced when you actually use it. And you can see, go down here. Let's just jump to the meat of it. So methods, there's only one method that it implements, compareTo, right? And so it describes how to do that and what the exceptions are, etc., and some things like that. But that's what an interface is in Java. Okay, so anytime you want to be able to take advantage of another Java feature, you may have to implement an interface in order to be able to take advantage of a Java feature, because that Java feature needs to be able to treat your class in certain ways. This is another example of polymorphism. Okay, the only reason that Java can write a method to sort any arbitrary class is through polymorphism. Okay, it's got a sorting routine built into it, and it's only because you implement this compareTo method that it can create polymorphic code to call any class. So it's another good example of polymorphism and why polymorphism is important to object-oriented programming. For practice hit problems, there are here's exercise 10.18 comparable point. So they'd have a class point2d with these methods here. It's a little bit confusing. They actually want, if you have a 0.56 and a 0.12, they want 0.56 to be greater than 0.12 because the distance of the origin is greater for 0.56 than 1.2. And remember, the distance of origin is it's the old square root of a squared plus of x squared plus y squared. And you can remember that there's a math.pow to square something, and there's a math.square root to take the square root of it. Okay, so you can calculate the distance for any point P, because there you can get the x and you can get the y, and you can figure out using this formula here what's the distance for point P and what's the distance for this. Okay, remember you've got this is the thing it's going to compare it to. So if this is 5.6 and the point P is 1.2, it should return 1. Okay, so remember these are all doubles, and you need to return an integer, either positive, 0, or negative. Okay, so there's a little bit of, it's not as simple as you might think. You have to make sure that you always return 1 as long as there's any difference between the 2 points, a 1 or a negative 1. Okay, but this is a good example for you to try for the comparable interface.